This video is the first in a series on periodic trends. Periodic trends are based on the periodic law, which states that elements are arranged in order of increasing atomic number or increasing number of protons. And because of that, they show a periodic repetition in their chemical and physical properties. The repetition of properties is known as periodicity. The general periodic trends that we'll be discussing in this series of videos include shielding effect, atomic radius, ionic radius, ionization energy, metallic character or metal reactivity, nonmetal reactivity, electronegativity, and electron affinity. Before we discuss these trends individually, let's begin by talking about the factors that are responsible for periodicity. There are two major factors in determining periodic trends. The first one we'll talk about is the effective nuclear charge. We use the symbol capital Z with an EFF in the subscript position to represent the effective nuclear charge. So you might be wondering, what is a nuclear charge? Well, think about what's in the nucleus that has a charge. Hopefully you're recalling that there are protons in the nucleus, and you'll hopefully remember that protons have a positive charge. So that is what we mean. We mean that when we say nuclear charge, we mean that we're looking at the number of protons in the nucleus. So where do the letter Z come from? Remember when we talked about the isotope symbol or nuclear notation, we would use the letter X to represent a symbol of an element. Then when we were writing the isotope, we would also use Z to represent the atomic number, also known as the number of protons. And we would use A up here at the top in the nuclear notation to represent the mass number of an element. So the greater the atomic number, the greater the number of protons in the nucleus. So Z represents, or Z with EFF next to it represents the effective nuclear charge, and just plain Z represents the number of protons. The second factor we're going to be looking at is the distance of the outer electrons shown here, also known as the valence electrons, from the nucleus. So in this picture, you can see that the nucleus is exerting an attractive force on the outer electrons, pulling them closer toward it. And that attraction, though, is offset by these repulsive forces. So you can see on the inner energy level that's pictured here, I'm marking it right now with my green pen, this inner energy level, if there's one or if there are more than one of them, we call these inner energy levels the core of the atom. This is where the core electrons reside. When there are more core electrons present, there is more repulsion between them and the outer electrons. And because of that, the attraction of the outer electrons to the nucleus is reduced, because the core electrons shield the outer electrons from the attractive force of the nucleus. So to recap, the nuclear charge of an atom is given by the atomic number. The outer electrons, or the valence electrons, they don't get to experience the full attraction of the nuclear charge, as they're shielded from the nucleus and repelled by core electrons. So when there are core electrons present, the effective nuclear charge, ZEFF, is less than the full nuclear charge. So these are the two major factors in determining periodic trends. Moving forward in the videos ahead, we're going to explore each of the periodic trends individually.